Hello dear students, in this session we are going to learn some basics about vectors. Okay, vectors are very important. Okay, but before that, as usual, I'll be giving you a problem. Okay, first solve the problem, then continue the video. Okay, a ball is thrown vertically upwards from the top of a tower of height 30 meter with the speed 25 meter per second. After what time from the beginning the ball will hit the ground? You can take g is equal to 10 meter per second square. I'll explain the problem for you. Okay, I'll give you a small hint. Okay, ball is thrown from the top of a tower with a speed of 25 meter per second. Okay, height of the tower is 30 meter. Height of the tower is 30 meter. Okay, the ball will go up and it will reach the ground. After what time from the beginning the ball will hit the ground? So this is the problem, this is the scenario. Okay, hope you will solve this problem. In the comment section your answer should come. Okay, now we will discuss vectors. What is a vector? There are two types of physical quantity. Okay, one type of physical quantity is scalar. Okay, a physical quantity can be a scalar, a physical quantity can be a vector. Okay, what is a vector? What is a vector quantity? If a physical quantity has both magnitude and direction. Okay, say for example, there is a body of mass m and there is a force of 10 Newton acting on the body. This force has got some direction. Okay, when you hit on someone, okay, you are applying a force. Okay, that force has got some direction. Correct now? But whereas mass of a body is 5 kg. What is the direction of mass? It doesn't have any direction. Charge, it doesn't have a direction. Gravitational field, okay, it has a direction. Gravitational field is always acting downwards. Okay, physical quantity. Example for vector quantities are force, okay, force, field, etc. Okay, example for scalar quantities: mass, okay, charge, okay, temperature, etc. Okay. Now we will learn how to add a vector, how to represent a vector and all. Okay, say for example, a vector is represented like this. A vector is generally represented like this. We call this as a tail of the vector, we call this as head of the vector, and length of the vector is its magnitude. Length of the vector is the magnitude and this arrow mark gives the direction. Okay, now we will study how to add a vector. Okay, for which we have something called triangle of vector addition. Okay, very important. Listen. Okay, now you have got two vectors. Say I have got two vectors. This is vector A, and somewhere here I have got another vector. This is vector B. How to add these two vectors using triangle of vector addition is, what I'll do, I'll write this same vector A here. Okay, this is vector A I have written here. This vector B, I'll write it here. See, I should not change the direction of vector B and I should not change the magnitude of vector B. The same vector I brought it here. Now see, this is tail of first vector, this is head of first vector, this is tail of second vector, this is head of second vector. If two vectors are connected in head to tail fashion, then the third vector, okay, which goes from tail of the first to the head of the second gives resultant. Okay, or this triangle law can also be defined like this. If two vectors are connected in order, okay, like this, okay, order, then the closing side of the triangle taken in the opposite order. See, these vectors are going like this. Now this is in the opposite direction. Correct now? If two vectors are connected in the order, if two vectors are represented as adjacent sides of a triangle taken in order, then closing side of the triangle taken in the opposite order gives the resultant. So resultant vector R is equal to vector A plus vector B. how to understand this better. Say for example, a person goes from this point to this point. Okay, first he goes in this path. Okay, he goes in this path. What happened effectively? What happened effectively? The person has moved from this point to this point. So this is the resultant. What is the result? Okay, resultant means result. Okay, R equal to A plus B. So this is triangle law of vector addition. So using triangle law of vector addition, you can also subtract vectors. Say for example, how to find A minus B? How to find A minus B? What you have to do? Write this vector A here. This is the vector A. Okay. Where is vector B? Vector B is this. This is vector B. How to find A minus B? A minus B means, okay, A minus B means A minus B is equal to A plus minus B. Means if you add vector A and vector minus B, then you get A minus B. For that, what you should do, if this is B, then this will be minus B. Correct? If this is B, then this will be minus B. Now, vector A and vector minus B are in order. Then the closing side taken in the reverse order gives the resultant. So this is the resultant. R is equal to resultant R equal to A minus B. Triangle law of vector addition can be used to subtract vectors also. Okay. Next, we will learn something called parallelogram law of vector addition. Okay. Here I take the same vector, same two vectors A and B I will take. Okay. Same two vectors A and B I have taken. Okay. How to use parallelogram law of vector addition? I'll write this vector A here. Okay. Then I'll place vector B here. I should place two vectors A and B such that they represent adjacent sides of a parallelogram. If vector A and vector B represent adjacent sides of a parallelogram, okay, then what you have to do? You complete the parallelogram. Okay. Now this parallelogram has got two diagonals. Correct? Now one is this and the other is this. According to parallelogram law of vector addition, the diagonal of the parallelogram starting from the common initial point, diagonal of the parallelogram starting from the common initial point will give you the resultant. So this is the resultant vector. Now if you observe in the when we use triangle law of vector addition, this was the resultant. Now you observe this diagram. Here also resultant is same, same. The resultant has same length and same direction. Correct? Triangle law, parallelogram law. Correct? Means both triangle law and parallelogram law can be used to add two vectors graphically. Both will give the same answer. What is parallelogram law of vector addition? If two vectors are represented by two adjacent sides of a parallelogram, then the diagonal of the parallelogram starting from the common initial point will give you the vector sum. Then how to perform A minus B? How to perform A minus B? We know that A minus B is equal to A plus minus B. Correct now? So where is our A? This is our A. Okay. Where is minus B? If this is plus B, this will be minus B. Hope you can understand. Then complete the parallelogram. This will be the resultant. This is the resultant vector. Hope you understood how to add two vectors graphically using triangle law of vector addition and parallelogram law of vector addition. Now we'll see how to resolve a vector. How to resolve a vector, we'll see. Okay. Say this is x-axis, this is y-axis, this is a vector. This is a vector A. Say this is a vector A. Okay. Now let us suppose that you take a torch. Okay, you take a torch and you switch on the torch. Okay. Then what happens? There will be shadow of this vector here in this portion. Correct now? So you call this as projection of vector A. See, this is projection of vector A. I call this as AX. Projection of vector A or component of vector A along x-axis. How to find y component. To find y component, drop a perpendicular from the head of vector A to the y axis. This will give you y component of vector. Means what? Basically, okay. So what I'm explaining is, say there is a block. Okay. One person is pushing the block in this direction. Another person is pushing the block in this direction. Where the block will go? Block will go like this, na? Correct, na? See, this is one vector. This is one vector. This is another vector. Where is the resultant? This is the resultant, no? According to parallelogram law of vector addition. Okay? Okay. Now here, see, this is our vector, vector A. And we have resolved this vector A into two components. Okay? One is vertical component, one is horizontal component. Okay? Now, angle between these two components is 90 degree. Therefore, we call them as rectangular components AX, okay, AX and AY are known as rectangular components of A. Rectangular components of vector A, rectangular components of vector A. Why we call them as rectangular components? Since angle between them is 90 degree. If the angle between the components of a vector is 90 degree, then we call them as rectangular components of a vector. Okay, now see, say this angle is theta. Okay, this angle is theta. What is length of this? What is length of this? Length of this is AY, correct na? Length of this is AY, because this is AY, so this is also AY. Now here you define tan theta. If I define tan theta there, what happens? Tan theta will be equal to opposite side divided by adjacent side, AY divided by AX. AY divided by AX, sorry. AY divided by AX. Or theta is equal to tan inverse of AY by AX. Theta is equal to tan inverse of AY by AX. Now what is the length of this vector? Length of this vector is A, correct na? What is length of AX? Length of AX is AX without vector symbol. Okay. Now what is AX we'll write. Okay, what is AX? In this triangle, or what I'll do, I'll clear this. Okay, I'll clear this. Once again I'll draw. Okay, the same diagram. There is a vector A. We have resolved this vector into two components. This is AX, and this is AY. Correct now? This is Y axis, this is X axis, this angle is theta. Okay, now this length is AY. If I define sine theta, what is sine theta? Sine theta means opposite side divided by hypotenuse. Sine theta, opposite side divided by hypotenuse. What is opposite side? This is what is the length of this? AY. Correct now? If this is AY, this is also AY. Divided by what is hypotenuse? A. So what is AY? AY is equal to A sine theta. AY is equal to A sine theta. Similarly, if you define cos theta, what is cos theta? Adjacent side by hypotenuse. What is this adjacent side? AX divided by hypotenuse. What is the hypotenuse? A. This implies what is AX? AX equal to A cos theta. AX is equal to A cos theta. Now what you do? You perform AX square plus AY square. AX square plus AY square. What happens? AX square means what? A square cos square theta plus AY square means what? A square sin square theta. Okay, or this can be written as A square is taken common, A square into sin square theta plus cos square theta. What is sin square theta plus cos square theta? 1. Correct na? Trigonometric identity. So what happens? AX square plus AY square is equal to A square. Or this implies how to find magnitude of resultant. A is equal to square root of AX square plus AY square. So this is how you can find magnitude of resultant. Okay. if ax and ay can, if ax and ay are given, if ax and ay are given, magnitude of resultant is found like this. Okay, if ax and ay are given, angle is found using the formula theta is equal to tan inverse of ay by ax. Hope you can understand. Now say for example, uh, we'll try to understand the situation. Say for example, say this is x-axis, this is y-axis. One more thing I should teach you. There is something called I cap. What is I cap? I cap is a unit vector. What is a unit vector? Okay. Before that, let me tell you what is a unit vector. Unit vector is a vector having magnitude is equal to 1. Magnitude is equal to 1. If the magnitude of a vector is 1, then we call it as a unit vector. Okay. If the magnitude of a vector is 1, then we call it as a unit vector. What is I cap? I cap is a unit vector along x-axis. Unit vector along x-axis is represented as I cap. For example, in the problem they give like this. Okay, for example, there is a force. Okay, there is a force of 20 Newton. There is a force of 20 Newton acting along x-axis. Along x-axis. There is a force of 20 Newton acting along x-axis. Then how do you write? You write this as F is equal to 20 I cap Newton. What does this 20 I cap represent? 20 I cap represents that 20 Newton force is acting along x direction. Unit vector is used to specify direction. Okay, what is I cap? I cap is a unit vector along x-axis. I cap is a unit vector along x-axis. I cap is a unit vector along x-axis. Similarly, j cap is a unit vector along y-axis. Similarly, k cap is a unit vector along z-axis. What is I cap? I cap is a unit vector. I cap is a unit vector along x-axis. I cap is a unit vector along x-axis. J cap is a unit vector along y-axis. K cap is a unit vector along z-axis. Now I'll tell you one important thing. Let us suppose that one vector is given to you. A vector A is given by 2i cap plus 3j cap. A unit vector, a vector is given by 2i cap plus 3j cap. How to represent this graphically? See, very, very important. Listen, x, y, along with the video. Do your notes. Okay, x, y. Okay, I cap means what? Okay, vector A has got a magnitude of 2 along x-axis. So I write this as 1, this as 2, this as 3, and so on. This is 1 here, 2 here, 3, and so on. Along x-axis, 2. This is 2i cap. Along y-axis, what is the magnitude? 3. Here there is one vector. So this is 3j cap. This is 2i cap. Now what is the given vector? Given vector A is this. What is this? 2i cap, 2 along x-axis, 3 along y-axis. 2i cap plus 3j cap. This is how you represent a vector graphically. Okay. Well, we'll solve one simple problem. Okay. What is the angle between the vectors? What is the angle between the vectors? Okay, two vectors are given to you. One is vector A is equal to 2i cap plus 2j cap, and vector B is equal to 3i cap. Okay, so this is x, this is y. So this is 1, this is 2, this is 3, this is 1, this is 2, this is 3. Okay, 2I cap, 2j cap. See, this is the first vector, correct? Now what is vector A? Vector A, this is vector A. What is that? 2I cap plus 2j cap. Okay, then what is vector B? Vector B is 3I cap. This is vector B. I'll use this. This is 3I cap. What is the angle between them? What is the angle between them? I think you can understand it is 45 degree. Correct now? But what we will do? We will use the concept that we have just learned. Okay, tan theta equal to ay by ax. Correct now? You remember? Theta equal to tan inverse of ay by ax. Okay, what is it? What is ay? Ay is 2. What is ax? Ax is also 2. So 2 by 2 is 1. So that is tan inverse of 1. What is tan inverse of 1? Theta equal to 45 degree. Okay, this angle, vector A is making an angle of 45 degree with the x-axis, and our vector B is along x-axis. So therefore angle between A and B is how much? 45 degree. Okay, hope you can understand. Now I'll give you one problem. Okay, so those who got the answer, please give it in the comments, write it in the comment section. What is the angle between vectors vector A is equal to 3I cap plus 3j cap, and vector B is equal to minus 3I cap. What is the angle between these two vectors? One vector is 3I cap plus 3j cap, other vector is minus 3I cap. Okay, solve this problem. Okay, and give the answer in the comment section. Hope you are taking the notes. This is very, very important. Okay, these 70 days till your first PUC class starts. Okay, you should not sit quiet. Solve the problems, solve maths problems, solve physics. Okay, every day listen to the class and do your notes. Okay, thank you very much.